Okay, guys, let's talk about proteins really quickly. And once again, what do you need to know? What trick can you use to remember things easily? So first and foremost, proteins they do everything. They are structure. They are in your muscle for contraction. Look at this week little video on muscle. You will see how those two interact and act. It's fascinating. It's amazing. This is just little hands pulling on little strings. It's a tug of war with your muscle, 1,000 times over. It's insane. I just love it. Go and look at the video. They help for transport. They help for storage, like the egg protein, and we also do storage with some protein. They are also what makes enzymes, which facilitate reaction. We talk about enzymes more. We talked about enzyme more as well in this class. So all of those really important. Also antibodies. This is what helps your body we reject infections and fight infections. Okay, they do a lot, right? But now, what is a protein? When you look closely, you realize that there is a lot of things going on, right? But first of all, we show you that main structure. What do you need to remember? Remember that the monomer of protein is an amino acid. That's what you want to remember. Monomer of protein, amino acid. Sugar was the monomer of carbohydrates. Amino acid is the monomer of protein. 20 different amino acids exist, but they all look the same. The only thing that varies is the R group. So that makes them look different, but the pattern is amino, carbon, central carbon, carboxyl group. Get that in your mind. Amino, central carbon, carboxyl group. Do you need to know how many H's and N and stuff? No. But you need to know that amino means N, nitrogen, central carbon, and then carboxyl means carbon with oxygen. That's all you need to know. Like you almost don't need to know how to draw those, but know that it's amino, carbon, and carboxyl group. And the R group is on that central carbon. If you want, if you have a periodic table of elements, you can work out how many uh, links there are and how many by default. You can work out that N has 3 vacancies on his last shell, so they must be linked to central carbon and 2 for hydrogen. That's it. So you need to know that. Now, do you need to know all those groups here that we show you? No, you don't. We just show it to you because we want you to be aware that all of those amino acids can be widely different from a simple H or glycine to tryptophan being a huge group here. We will know, we will learn how proteins are made during translation that we'll learn later in class. But we won't ever talk about the details of those. You may want to know those details, but they're not necessary for this class. It's interesting to know that some are ringed, some are not. Okay, now think about patterns. Dehydration synthesis, hydrolysis. We find the same pattern as in carbohydrates. See how we can now summarize all of those as an amino group, carboxyl, central carbon, and the R groups. And look at those OH-H. You can also remove OH and H and bring it together with what we call a peptide bond. So now the carboxyl group has lost an OH. The amino group of the next peptide amino acid has lost an H, which makes a peptide bond between the two amino acids, making a protein. Now we have several amino acids together. It's a protein, a peptide. So really look for those patterns. Now, something you need to know is, sorry, is really the structure. So a protein structure starts with a primary structure being simply the link of the different amino acids. So if I want to draw them real quick, you can think of it as a string of beads like that, and that would be tryptophan, that would be glycine, and methionine. That would be the primary structure, which amino acids are in which order, which you can see here. One amino acid, another one, bonds every time. We don't need to know the R groups here. That's the primary structure. Now, if you think of a secondary structure, that's when those will form folds. They can be either alpha helix, so those hydrogen bonds do everything again like protein. They help connect. You see the oxygen here? The remaining charge of the oxygen will connect to the remaining charge on that hydrogen. Why is there remaining charge about oxygen? Well, look at it. That carbon here has 4 bonds, but 2 that are opposite in cardinal opposition, so north and south, and that one goes to the right, the east, and nothing opposite to it. So there will be remaining charges. You can work that out again as we did for water. And same here, that N here has 3 bonds, but 2 are opposite and 1 stick out one side, nothing on the other side. Those are remaining charges, those are hydrogen bonds. There can be alpha helices when the chain, primary chain circles. There can be beta sheets in which that chain here, and I want to show it to you in another way here, the chains are folded in sheets. And it's important to realize that the first here and the second are linked with those hydrogen, but it's not different peptide. That's the same peptide that can be doing an helix here and go back here. We just don't show it to you here, but those chains are connected somehow. So it could be like that on that side, you go there, you do a side, you go there, you do an alpha, and you go back here, right? But those links link the different sequence, primary sequence together. So that's like not showed, but they are linked. They can be directly linked, or they can have a lot of things happening before it goes back and linked to another sheet, right? So that's an important thing to remember, the secondary structure. Now the tertiary structure is when one peptide, so one chain of amino acid, comes together and you have several of those beta, alpha structures, but it's only one long chain, right? The quaternary structure is when several of those chains are now interacting with each other, right? So that one chain here is right there, and then another of them come here, and there are interactions between the two. And when all of those peptide chains interact, that's called quaternary structure. Tertiary structure, primary, secondary, tertiary, it's one peptide chain. Quaternary is when several peptide chains come together. Some proteins don't have quaternary structure because they are only made of one peptide chain. So not all proteins have quaternary structures, but all proteins have a tertiary, primary, secondary structure. If they don't, it's because you cooked them. So if you cooked it, you lose all the secondary and tertiary structure, and you are left with a primary structure alone, right? That's it for proteins. Think of patterns, learn the primary, secondary, tertiary, quaternary structure of proteins, and you'll be golden.